Okay, even though I gave you the answers to this review packet, I want to go over how to do all the problems so that you can study. I don't know if that makes sense, but let's look at number 1. Shall we? Great. Okay. At which of the 5 points are the first and second derivatives both negative? Well, you can automatically rule out C, D, and E because these have second derivatives that are positive because the function is concave up. So that means that it's either A or B. At A, the first derivative is positive because the slope of the tangent is positive. At B, the slope of the tangent is negative and the function is concave down, which makes the answer B. Okay, so let's talk about the extrema of x to the 4th minus 2x cubed. So let's look at that problem. The first derivative is 4x cubed minus 6x squared, which we know looks like that, right? Second derivative is 12x squared minus 12x. So that's parabola. We also know that if I set 12x squared minus 12x equal to 0 and factor out a 12x, that the zeros are at 0 and 1, the zeros of the second derivative. Points of inflection, if you will. Okay, so the function has no relative extremum. Well, we know that's not true because this obviously is going to equal 0 at some point. Let's solve that. Where I'm going to factor out a 2x squared, leaving me with a 2x minus 3. So here the zeros are 3 halves, and there's a 0 at 0. However, it has an even multiplicity. When a derivative has an even multiplicity, that means it doesn't change sign. And remember, maxes and mins happen where the first derivative changes sign. So it's really, really important that you understand that because this is an even exponent, 0 is not a max or a min because the function doesn't change sign. At 3 halves, you could think about the graph and notice that it's whether it's a max or a min, or you could pick a number on either side of 3 halves. For instance, if I plug in 1, you would see that this would be 4 minus 6, it would be negative. And if I plug in 2, this would be 32 minus 24, that would be positive, which makes this a minimum, right? But it doesn't even ask that. It just says the graph of the function has 1 point of inflection and 2 relative extrema. Well, we know that's not true because we found that it only has 1 relative extrema. 2 points of inflection are 0 and 1. Now, again, if this had been x squared, then we wouldn't have considered, well, it still would have been a point of inflection. No, I don't think it would have been actually, because the same thing goes for this, that in order to be a point of inflection, the second derivative has to change sign. Don't hold me to that. We might have to look into that further. But I do know for a fact that if the first derivative doesn't change sign, then it's not a max or a min. So 2 points of inflection, 1 relative max or min. In this case, it's a min. Okay. Whew, that was a toughie. Particle moves along the x-axis in such a way that this is given. What's the acceleration at t equals 0? Well, first we have to find x prime of t, otherwise known as v of t. We'll just call it v of t. Okay, so bottom times derivative of the top minus top times derivative of the bottom, which is 1, so I'll just leave that alone, all over 1 plus t squared. Now I have to take the derivative of that, but let's simplify this first. This is negative 1 minus t minus 1 plus t. So the t's cancel out. I just get negative 2 over 1 plus t squared. That's still v of t. I just simplified. Okay. Well, I'm going to rewrite this as negative 2 times 1 plus t to the negative 2, just because I like exponents better than quotient rule. So now a of t, negative 2 times negative 2 is 4, times 1 plus t to the negative 3, and the derivative of the inside is just 1. So this is my answer, and when I plug in 0 for t, I get 1. 1 to the negative 1/3 is still 1, times 4 is 4, which is why the answer is 4. Okay. here, okay, this answers the question from before. At which values of x does it have a point of inflection? When the second derivative changes sign, not just where it equals 0, where it changes sign. So that's why we rule out -4, because at -4 it has an even multiplicity, which means it doesn't change sign. It's tangent to the x-axis. So 0 and 7/3 are the only correct answers there. Okay. How many points of inflection does this have? This is the derivative. So points of inflection are when the second derivative equals 0. So it looks like 1, 2, 3, 4. Again, second derivative equals 0 here, 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 and here. 4 points of inflection. The derivative of sine to the fourth of 3x is 4 sine cubed of 3x times cosine of 3x times 3. So 4 times 3 is 12. Sine cubed of 3x times cosine of 3x is choice B. Let's think about this graph. F of 0 does not exist. I disagree. 0 to the fourth is 0. The fifth root of 0 is 0. The limit as x approaches 0 does not exist. I disagree. This function is continuous at 0. And pretty much, I can't think of anywhere that it's not continuous, because anything to the fourth power is going to be positive, and you're going to take the derivative of, I'm sorry, not the derivative, the fifth root of a positive number. So your answer is always going to be positive. So it's not undefined anywhere. Well, yeah, it's not undefined. So f prime is continuous for all reals. Well, f prime would be 4/5 x to the negative 1/5, which is 4 over 5 fifth roots of x. So that is continuous for, not for all reals, because it's not continuous at 0. Okay, so we've proven that the first three things are not true. F prime of 0 equals 0, I disagree. It's undefined when it equals 0. Remember, this is f prime of x. F prime of 0 does not exist. That's true, because the denominator would be 0. So that's a hard one, because it says which one must be true. You're not used to reading things that are all false, but these are all false. All right, average rate of change. Plug in 3, and you get 81 minus 15 is 66, minus 0 over 3, which is 22. That's it. Final answer. Okay. Blah, blah, blah. Limit as x approaches infinity. Check your exponents. I see a 2 and a 2, which means it's coefficient over coefficient. 3 over -6 is -1/2. Here we go. Derivative of this is derivative of the outside, leave the inside alone, times derivative of the inside. We're talking about 1. So g of 1 is 2. F prime of 2 is -4. G prime of 1 is -3. -4 times -3 is +12. Okay, so for what values of t is the particle at rest? So when does the velocity equal 0? So velocity is 3t squared minus 6t minus 9. We want to know when does that equal 0. Factor out a 3. And then t minus 3, t plus 1. T equals 3 and -1, but t is greater than or equal to 0, so we rule out that. So it's only at 3. Alrighty, number 12. You have to recognize, this is really important. This shows up on AP Calc all the time. This is the difference quotient. Remember when we first started learning about derivative, we used the difference quotient to figure out what it was. Then we said, here's a trick. So you have to recognize that this is just asking you to find the derivative of tangent of 3x. That's all it's saying. So your answer should be B, I think. Yes, because it's 3 times secant squared of 3x. It's just the derivative of whatever this is. Okay, that's always true. Okay, this one I remember being a little bit tricky, so I'm going to do this one on a separate sheet of paper. I have f of t equals 1 over t for t is greater than 0. The average rate of change on the interval a to b. So the average rate of change is 1 over b minus 1 over a all over b minus a. That's just slope. But let's simplify this. Multiply this by a minus b over ab times 1 over b minus a. Okay. These cancel with a negative 1. So you're looking at negative 1 over ab. We want to know for what value of t is the derivative of this equal to this. So the derivative of 1 over t is negative t to the negative 2. When does that equal negative 1 over ab? Well, first let's multiply both sides by negative 1. So now we just get t to the negative 2 equals 1 over ab. Remember, t to the negative 2 is 1 over t squared. So cross multiply, and you get ab equals t squared, and then t equals the square root of ab, which is choice B. Okay, that one had a lot of steps to it, but hopefully that made sense. All right. Let f be a function that is differentiable on the open interval. Now, you have to recognize that when it says differentiable, that also implies that the function is continuous. So if we think about a function from 1 to 10, if it has to be continuous and differentiable, that means we're not looking at any cusps, we're not looking at any asymptotes, we're not looking at anywhere that the first derivative doesn't exist, which means it must be continuous on this whole interval. So if f of 2 is negative 5, which is down here, and f of 5 is 5, which is up here, and f of 9 is negative 5, which is down here, the function has to look something like this. Now, it could go like this, right? But it has to be continuous because it says it's differentiable. So f has at least 2 zeros? Absolutely. It has to go, because it goes from negative to positive to negative, it must cross the x-axis at least 2 times. The graph of f has at least one horizontal tangent. Well, it must have a max, because it has to turn around and come back down. For some c must be between 2 and 5. F of c is 3. Now this one's a little bit confusing because as soon as you see c, you start to think of the mean value theorem. It talks about the derivative, which that's confusing. But this doesn't say anything about f prime of c. It just says somewhere between 2 and 5, there must be a y value of 3. Well, that's true because we know it's going through 0 at some point, and it has to get up to 5, and then it has to come back down. Well, from 2 to 5, it goes from negative 5 to 5. It must hit every y value in between negative 5 and 5 because it's continuous. So all 3 things are true, and 14 is choice E. 15. Oh, how I love this question. Product rule. First times derivative of the second plus second times derivative of the first. So we're talking about 3. So we need f of 3 times g prime of 3 plus g of 3 times f prime of 3. Well, f of 3 is 1. G prime of 3, that means what is the slope of the tangent here? Well, if you look at the line, it's a constant and the slope's 1. So the derivative is 1 everywhere. G of 3 is 3. And the slope of the tangent here is negative 1/3. So 3 times negative 1/3 is negative 1, and 1 minus 1 is 0. So choice 0. Okay, find f of negative 2. If it's continuous for all real numbers, that means factor. Cancel that. Plug in negative 2, and you get negative 4. Choice A. Okay, here's where the changing sign thing comes again. So the first derivative goes from positive to negative at negative 1. Then at 2 it stays negative. And then at 5 it goes from negative to positive. So it has a relative extrema at negative 1 and 5. Relative extrema at negative 1 and 5. So I can rule out B And that's it for right now. Points of inflection are the same thing. Well, here it stays, second derivative stays positive, so -1 is not a point of inflection. So that rules out C and A and E, because it does have a point of inflection right here. Right here it has a point of inflection where it goes from positive to negative at 2 and then negative to positive at 5. So there's your 2 points of inflection, and there are your 2 extrema. So it's choice D. 18. First times derivative of the second plus second times derivative of the first. However, you know what y prime equals. You know that it equals x squared y squared. So now we have x squared times 2y times x squared y squared plus 2xy squared. So if you multiply all that out, you get x to the fourth, 2x to the fourth y cubed plus 2xy squared. Choice E. The hardest part there is recognizing that you know that this equals that. Okay, here we go. This is the derivative. The point 3,5 is on the graph of the original function, an equation of the line tangent to that graph at 3,5. So when x is 3, the slope of the tangent is 2, because the value of the derivative is 2. So you're looking at y minus 5 equals 2 times x minus 3. Choice C. How many points of inflection does it have? Well, how many maxes or mins does the derivative have? 1, 2, 3, 4, 5, 6 points of inflection. Choice E. And if you think about it, here the second derivative goes positive, negative, negative, positive, positive, negative, and so on. Just because it's tangent here, all this means is that the original function does not have a max or a min right here. That's all this means, because the first derivative didn't change sign. The original function only has a max here, where it goes from positive to negative. That's it. Okay. This is the velocity, so to find the average acceleration, we find the slope of the velocity. So from 0 to 20, do 120 minus 0 is 120, divided by 20 is 6 feet per minute squared. Now we have calculators. So on my calculator, I would type, I'll show you. So we want to know, when does the first derivative go from positive to negative, because that's what a maximum is. Oh, and they give you the first derivative, you don't even have to find it. So might need these later. So all I'm going to do is type in sine of x cubed and I'm going to look at where the graph goes from positive to negative between 0 and 2. So I have to change my window. I only want to look at 0 to 2. Zero to 2. Oops. And the y values I noticed are very small. Let's just go from -1 to 1. What am I doing wrong? Maybe I'm not in the right. No, I'm in radians. Y equals sine of x cubed from 0 to 2. Oh, that's my problem. That's better. Okay, so you can see it went from negative to positive, and then it comes right back down and goes from positive to negative right there. So I need to find what that point is. So I'm going to go second calc 0, and to the left of it, to the right of it, 1.46. Choice C. Okay, number 29 says the table shows the functions in the derivative of x equals 1. So to find the derivative here, we have to do first times derivative of the second. So 2 times f of x plus 3, that's first, times derivative of the second is g prime of x, plus second, 1 plus g of x, times derivative of the first, which is 2f prime of x. And then we just plug in. F of 1 is 3, 2 times 3 is 6, plus 3 is 9, g prime is 4, so 9 times 4 is 36, plus g of x is negative 3, 1 minus 3 is negative 2, 2 times f prime is negative 4, which makes this positive 8, 36 plus 8 is 44, and I believe that is the correct answer. Okay, the figure shows the derivative on the function. If it has 4 zeros from negative 7 to 7, how many relative extrema does f have? If f prime has 4 zeros, how many relative maxima does f have? How many times does this thing go from positive to negative? And I would say it's only once right here. Has to go from positive to negative, has to change sign. Okay, 31, sorry, you don't know how to do that yet. That's our next section after midterms. 32. The graphs of derivatives and their functions are shown. Which of the functions have a relative max on the open interval a to b? So again, where does the derivative go from positive to negative? And I would say that this is the only one, f. Okay. Which of the following could be the graph of h prime? So our function is increasing until right about here. So I need a function, I need one of these to have a 0 at right there. So this one doesn't, and this one doesn't. This one might, this one might, this one might. They all seem a little bit, anyway, we'll keep looking. Then I need it to be negative from here to here. Well, that's not. These two might be. And then I need it to be positive all the way again. Now the other thing I have to notice is that the second derivative is negative and then positive, and that's it. It doesn't go anywhere else. Well, you can see here the second derivative would be positive, then negative, then positive, then negative. So this one's out. So the only possible answer left is E. Okay. 36. Again, trying to figure out which one is the function and its derivative and its second derivative. So let's pick one. Let's start with number 1. If number 1 was the function, then its first derivative would be negative till right here, and then it would turn to positive because it's decreasing and then increasing. Well, neither one of these two things crosses the x-axis at this point. So that rules 1 out for being the function. What if 2 was the function? If 2 was the function, then its derivative would be positive to here, and then negative to about here, and then positive again. Now notice I kind of just described 1. So I'm going to say that graph 1 is definitely the derivative of graph 2. However, do I know that 2 is the original function and that would 3 then be the second derivative? Well, let's think about it. Let's keep going with 2 being our original function. If 2 was our original function, then the second derivative would be negative to about here. Well, that rules that out because graph 3 is not negative at all. It's positive the whole time. But it could be that 2 is the derivative of 3 and 1 is the derivative of 2. So let's see what would happen there. If 3 is the original function, then it should be negative for a little bit and then a little more negative. So it appears to have a min or a max because it bottoms out a little bit, but it doesn't actually change from decreasing to increasing. So that describes this graph. It's tangent to the x-axis there. And then it's still negative, and it doesn't turn to positive until right here where it starts increasing again. So we just answered our question. 3 is the function, 2 is its derivative, 1 is its second derivative. Okay. Let f be a function which is continuous on 210 whose derivative is given by that, which is true about f of x on the interval. So what's true about the original function? Well, let's take a look at the graph. Cosine of x over 1 plus x squared. Cosine of x divided by 1 plus x squared. And the interval is 2 to 10. Remember, we're looking at the derivative. This is the graph of the derivative. You can see that the derivative goes from negative to positive, and then it gets a little hazy in here, so let's change the window so we can see a little bit more. I'll go from negative 0.5 to 0.5. There you can see the derivative goes from negative to positive, and then positive to negative, and that's a little tricky over there, so let's look at the table and see what happens around 10. Okay, so it has 2 relative min and 1 relative max. Well, we said it goes from negative to positive once, which would be a min, and it goes from positive to negative once, which would be a max, but we have to see what's happening over here. You can see that at 10.5 or so, it goes from negative to positive, but that's after 10, and our interval only goes till 10. So it appears to go from positive to negative around 7.5-ish, and it goes from negative to positive right there, and it goes from positive to negative, but our interval starts at 2. So looking at the graph, make sure my interval starts at 2. Yeah. Looking at the graph, I would say negative to positive once, positive to negative once. Points of inflection, it appears to have 3. 1, 2, 3. And I can show you how to check that on the calculator too, but let's make sure we get the right answer here. 1 relative min and 1 relative max. We already talked about that. Now, let's say you're like, oh, I'm not so sure about the second derivative equaling 0 there. Well, what you can do is go into y2 and go to math 8, and we're going to go d dx of y1 from x, oopsie, that's supposed to be an x there, and in there, I'm going y1. So you can see that it has a point of inflection right there, and if you follow it along, you'll notice that it has 3 points of inflection, 3 places where the second derivative goes from change of sign. Okay, 1, 2, 3. All right, last question. Sorry, this is a really long video, but hopefully you watch it before your midterm and it answers any questions you might have. Mean value theorem. All you do, find the slope, so plug in 3. 3 squared is 9, negative 18, plus 3 minus 2 is negative 17, minus, plug in 1. Negative 2 plus 1 is negative 1, minus 2 is negative 3, so negative 17 plus 3 all over 2 is negative 7. I want to know, where does the first derivative equal negative 7? So I subtract 1 from both sides, and I solve, and I see that it's at x equals 2, which is choice D. That's it.